Okay, Assalamualaikum warahmatullahi taala wabarakatuh, and a very good evening. A very good morning to all of you. Today I will be giving, I think because we have actually talked about inductive and deductive reasoning before, than the one that I basic. Sorry, So, okay, so it will be a little bit detailed than the one that I have actually explained to all of you before. Okay, so let's do some let's recap what we have learned so far. So when we talk about evaluating an argument, we'll be looking at the types of argument, whether they are deductively reasoned or inductively reasoned. So for this topic, we'll be focusing on inductive argument, or an argument which is inductively reasoned. Okay, so inductive argument means that an argument in which the premises are intended to provide support but not conclusive evidence for the conclusion. Always remember that. That means when we talk about inductive argument, the conclusion is indefinite. Okay, and then when we talk about strong inductive argument, it means that an inductive argument in which the premises actually do make the conclusion more likely to be true. Okay, and then when we talk about cogent inductive argument, a strong inductive argument with true premises. Okay, and how can we actually know if the argument is inductive? Now, the argument is inductive because the argument is invalid. So if, let's say, you notice that the presented argument invalid, therefore the charitable thing to do is to treat it as inductive. Okay. Now, indicator words like likely, probably, plausible, possible, they are used to support or to show that the argument is inductively reasoned. Now, let's talk about inductive generalizations. Now, generalization is basically statement made about all of most members of a group. For example, if I have 10 people in a group and 3 of them like to eat chicken, then I am generalizing by saying that most likely all of them like chicken. Now, inductive generalization is where inductive argument that relies on characteristics of a sample of a population. That means a portion of the population. Kalau ada, let's say 4,000 people, kalau sample population dia is 200 people, then we focus on this 200 people, and based on this 200 people, we will somehow come up with a generalization, and that is to make a claim about the population as a whole. Okay, now give an example. All UiTM students that I have met so far have been rather generous. So as I was working in UiTM, and as I passed by and met UiTM students, most likely about 20 of them, they are all generous students. I asked them to donate, they did. So all UiTM students that I will meet later will be generous. This is an example of inductive generalization, because based on the small population, which is 20 people that I have met so far, I am making a generalization about all UiTM students by saying that they are all generous people. Now, making inductive generalization stronger by making the conclusion weaker. Now, as you notice, all UiTM students that I have met so far have been rather generous. So all UiTM students that I will meet later will be generous. It's a pretty weak argument. Why it is a weak argument? Because even if that person meets UiTM students often, UiTM is a big university, and his experience, my experience of meeting UiTM students, is not enough to justify such a sweeping conclusion. I mean, I have just met 20 students so far. in comparison with the number of UiTM students for about, I don't know, maybe 200 to 250 students. 20 students compared to 250 students. However, if we change the conclusion, and that is by using the word like most of the UiTM students, or better, many of the UiTM students, then the argument will be much stronger. So instead of saying that all UiTM students, blah, 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 I'll say something like this. All UiTM students that I have met so far have been rather generous, the 20 students, remember? So most of the UiTM students, or perhaps many UiTM students that I will meet later, will also be generous. So that makes my argument stronger. Simple, yeah? Now, evaluating inductive generalization, there will be 3 questions to ask. Number 1, are the premises true? That one will be covered in chapter 8. Number 2, is the sample large enough? Now, in general, the larger the population you are generalizing, the larger your sample population is. For example, if I were to have 4,000 students, 250,000 students in UiTM, so my sample size or sample population will be even bigger. Now, what is basically sample population? Sample population means that a group of people that best represent the whole group of people. I mean, hypothetically, if I were to have 250 students in UiTM, I cannot be making a survey to each and every single student in UiTM. So I have to have a sample of population. So it's basically a table. You can find it on the internet that tells you the number of the actual population and the number of people that you should be giving your survey to. So if let's say 250,000 students or 250,000 people, then how many people should you be surveying for? So not 250,000 entirely, but of course they have the so-called table. The whole thing, we call it sample population. And of course, the last one is whether the sample representative. Now, only if the sample shares all the relevant percentages with the population as a whole. So maybe the person who met your ITM students, which happens to be me, teach them. So maybe the 20 students that I met so far are the students that I taught or that I have taught or I am teaching currently. That's why they appear to be generous. So that means there's a likelihood that students that I have not taught before could have not been generous. Now, opinion polls and inductive generalization, when we talk about polls, yeah? Now, take a population of 100 million and take the representative poll is 4,000 voters. Now, how do you get 4,000 voters? Remember, I talked about the so-called jadual ataupun that table that is available on the internet. You can actually find them, search for them, yeah? So there is a 95% chance that the percentages of the 4,000 will fall within 2 percentage points of the whole population. So if 60% of the 4,000 voted yes, there would be a 95% chance that 58% to 62% of that 100 million voted yes. So we call it 60% plus minus 2. The smaller poles have bigger margin of errors. So plus minus 2, we call it margin of errors. Lagi small pole tu lagi bigger margin errors tu. For example, if we were to have 100 people in population, margin of errors will be plus minus 11. Kalau kita ada 1,500, then margin errors will be plus minus 3. But this only holds if the sample population is representative. That means to find the whole population's opinion, you can't just poll the rich or those with houses or those with radio because they listen, or people who are happy. Tak boleh lah, because it has to be representative. Representative means that it represents the whole population. So for example, if I want to contest in a parliamentary seat election, now, I want to see whether the people who are living in my constituents, whether they support me or they like me. So I come up with a survey. How do I distribute the survey? I pass it to katakanlah ada about 80,000 voters ataupun registered voters, kalau according to the so-called sample of population, just say lah, let's just say 80,000, maybe I should be giving my survey to 230 voters. So I will be focusing on that 230 voters lah that represent the 80,000, yeah. Tapi when I distribute the questionnaire, I use Google Form. So 230 voters ni, they have access to the internet, they have access to the laptop. But is it representative? Because what about those who do not have access to the internet and laptop? They are not represented in that 230 voters too. That where I need to get some of their to see whether they like me or not. Okay, so that is why your sample of population has to be representative. All right, so which means that you have to be fair and square and try your very best to avoid bias. Now, statistical arguments it goes the other way compared to generalization. They take generalization and draw conclusion about smaller samples of population. Example, you're a college student. So 90% of college student, they do not want cumulative final. So you probably do not want a cumulative final. So the more broad the conclusion, remember, and this line is very important, the more broad the conclusion, the better untuk statistical arguments. And statistical argument falls within inductive arguments, yeah? So the more broad the conclusion, the better. The higher the original percentage, the better. For example, if you have like a 50% percentage, that will be the conclusion. Another one is 70% percentage. So which one is even better? The higher, 70%. Kalau rule of thumb, if it is reasonable for you to bet on it, then it is reliable. That means dia lagi bagus lah, the argument, kalau you can place a bet on it, yeah? Now, in a statistical argument, if you find out more information about the person in question, you narrow the group or the class the person is in. For example, you are a college student who likes essays. 85% of college students who like essays, they want cumulative finals. Thus, you probably also want cumulative final. Now, this additional information student who likes essays will weaken your justification for believing that you do not want a final. Nampak tak? So the more information you have for that person, the more chance for that person to be the opposite of the given. Tadi kalau you tengok the conclusion is you stand a chance of not wanting the cumulative final, kan? Tapi because now you are students who like essays. And apparently, they did a survey, 85 of them who like essays, they nak pula cumulative final. So that means you dah fall in that. So the more narrow or the more information you provide, the narrow the conclusion be, itu the opposite of this. Remember saya cakap tadi, the more broad the conclusion, the better. So now that the conclusion becomes narrowed, it's the opposite. It's not the better, it becomes worse lah. Okay. Next is argument by analogy. This is also another type of inductive argument. Now, what does it mean by analogy? Comparison of things based on similarities. Simple. If I want to talk about something for you to understand, then I use another analogy that cause you to understand better. Okay, so argument from analogy is basically an argument that suggests that the presence of certain similarities is evidence for further similarities. For example, A and B, they have characteristics X. A also has characteristics of Y. So B probably has characteristics of Y too. Kalau kita cakap dalam bentuk layman's example Tiffany and Heather are both tall and they play basketball. Tiffany at the same time plays volleyball. So Heather probably plays volleyball too. So this is what we call argument by analogy. And when we talk about evaluating arguments from analogy, these are the questions that you may want to have in mind. Yeah, you can just go through these questions and see if, let's say, it fits with your argument from analogy. Then you can see whether your argument is strong ataupun weak. Now, arguing by analogy ataupun from analogy, you employ the same questions as you are evaluating. Yeah, for example, don't be too specific. These are some of the tips that I can share with you. Make sure that your argument is not too specific. Make sure you use relevant similarities. Make sure you use many similarities. Use a diverse and large group, and most importantly, use true premises. Now, induction and causal arguments. Causes, they precede and are constantly conjoined with their effects. For example, on a billiard table, we constantly see the cue balls striking off the other balls just before they move. So we assume a causal connection. And if we were to argue that they are causally connected, we would cite the fact that the cue balls striking of the other balls always precedes and is constantly conjoined with the movement of the other balls. But as we learn in chapter 6, two things being constantly conjoined isn't enough to conclude a causal connection, because this langgar this, therefore this causes this to happen. Not necessarily, because we know well there are many other factors that cause this to happen as well. Coincidentally, they all happen at the same time. So additionally, one thing preceding another is not enough for us to conclude a causal connection. So how can we conclude? How can we argue and conclude that two things are causally connected, that this caused this to happen? So, two kinds of causal arguments. The first one, arguments about a single sentence. For example, my car wouldn't start, but I haven't replaced the battery in 6 years. So it must have been the battery. So this is just an argument about the cause of one event. The next is argument about a general relationship. For example, there is a high correlation between smoking and lung cancer. Now, smoking must cause lung cancer. So this is just suggesting a causal relationship between smoking and lung cancer, but not about a specific person's lung cancer. And also notice that it isn't saying that everyone who smokes gets lung cancer. The statement is pretty generic. You smoke, high chance you'll get lung cancer. Simple, yeah? Now, bear in mind that the dangers of correlation. Now, truth be told, we can never prove beyond doubt that there is a causal relation between two things. Tak boleh, we can never prove. The best we can do is to observe the correlation. But then again, correlation is the best we can do when it comes to arguments of causation, yeah? But when arguing from correlation, one must be careful, because we have the tendency to see things as correlated when we already think that they are causally related. Beza antara correlated and causally related. For example, you you were not paying attention, and because of that, you, as you go out from your house, you accidentally step on the cat's poop. Again, I repeat, yeah? Because you were not paying attention, on your surrounding. As you go out from the house, you accidentally, um, step on the cat's poop. That is what we call causal relation. But somehow we try to connect that situation with bad luck by saying that that's it. I mean, keluar je pagi-pagi, you'd accidentally step on the cat's poop. That's it. There goes my day. It's gonna be bad luck all the way through. That one is correlation. That one is correlation. So by just saying sometimes we feel that these are correlated when the fact is they are just causally related, bukan correlated at all. And because of this confusion, it leads people to have superstition, belief of bad luck, etc. By assuming that they are connected when trying to prove that they are, begs the question. Now, to really establish a link, we must be careful to eliminate bias and expectation. So when you are able to eliminate bias as well as expectation, then we can say that this one thing, there is a correlation between smoking and lungs cancer. So how to eliminate those things? Through experiments. Simple. But even large amounts of correlation are not enough to establish a causal connection. Large amounts of correlation, but it is not enough to cause or to establish causal connection. So you want to know better about this, you can look at the example on page 327, yeah? And when arguing from correlation, you need to make sure that there are not any other factors that might account for the correlation. There's also another example on vitamin C study, page 329. There are two types of correlation. We call it positive and negative. Positive correlation, if A is found together with B, 50% or more of the time B is found. Whenever you found B, there'll be A. You found B, there'll be A. And it is 50% or more. Then A is positively correlated. However, if A is found together with B, 50% or less, 50% or less, then A is negatively correlated with B, which means that A prevents B. Kalau yang first tadi positive correlation, A causes B. Kalau negative correlation, A prevents B. But all in all, correlation is most often due to coincidence. Even if X is correlated with Y, it could be due to the fact that they are both the causal result of some other thing, for example, Z. So it is wise to always be suspicious. Sebab itu, you must be able to eliminate, cerita tadi itulah, bias and expectation so that you know that this is the only reason as to why this happens. Itu saja. Okay. Now let's talk about probability. Another type of argument falls under inductive argument. There are three types. We call it epistemic probability, which expresses how likely we think something is, given what we believe. So there is a pretty high probability that I'll go to the beach sometime this summer, because that's what we believe in. Whenever summer, we go to the beach. Or it looks like raining, so that means I will be using the umbrella. To epistemic probability. Because it's raining, given that understanding, we'll just use the umbrella. Next is relative frequency probability. Ini pernah keluar probability ni, types of probability ni. So you may want to really understand. Takes information about a group as a whole and applies it to individual. For example, doctor, do you think that this surgery will be a success? Well, there is a 90% chance that the surgery or the operation will be successful. Now, when a person says that there's a 90% chance, it means that is derived from the fact that 90% of the people that went for the operation and it became successful. Itu yang dia cakap 90% tu. And this is what we call frequency probability. The last one, it is called as priori probability. Now, priori probability can be counted depending on what are the chances. Now, if I were to toss a coin, there is a 50% chance of getting the head. Similarly, 50% chance of getting the tail, because there are only two sides. So you can count them. When you can count the probability, that is what we call priori probability. So these are some of the clues for you to understand better lah about priori, epistemic, and frequency. Pernah keluar. And how to basically count priori probability. You can go through this, but I am not going to explain in details because number one, people use priori probability, particularly in gambling, because they want to count the probability. So the higher the percentage is, the greater chance of you winning whatever playing games that goes on that table and whatnot, or during the gambling. So you can just read this, and for you to understand better, you can just read from the one explained in the textbook. And I guess that is all for today. Thank you so much for watching and listening to my lecture. Should you have any question, we can have that so-called discussion later on as we meet up. That will be all for today. Thank you so much. Assalamualaikum.